Hello everyone. Today in this video, I will be showing how to use PySpark to demonstrate data modeling, and I will be using k-means clustering algorithm for this purpose. So just to introduce k-means algorithm is a clustering algorithm which aims to partition n observations in the clusters. In this, each observations belong to a cluster to the nearest mean. So k-means algorithm goes with minimum sum of squares to identify the data points. So this is the k-means algorithm code which I will be using for this purpose. And here I'll be using PySpark ML library. So ML library is the machine learning library which gives all the inbuilt functions of machine learning in the PySpark. So the first step is to import all the necessary PySpark libraries which are needed in this code. So we have k-means and we have Spark context. So this section has all the libraries which are needed and they are imported. And the next step over here is to load the data set. I will be using ID's data set from this machine. And the next step is to pass the data. And as you can see, the pass data statement is right over here, which has data.map. Data.map is to load the data set, and the split function is used to split by the comma. So as you run this, you can see that it contains Python RDT. So this statement is to load the first 5 rows of the dataset and to see if the dataset has been loaded correctly or not in this code. So next part what we will do is when we do some classification, we use only those parameters which are used to predict the actual class of the data. So the parameters which are not used, you can omit those, and you can only take those parameters which are used, which are useful over here. So that's what we have done here. And in the next step, we are just seeing the contents of the dataset, and we are taking only 5 rows to display that. Um, so in the next step, we evaluate clustering by computing the within set sum of squares error. We identify within set sum of square errors and we use that to group the data points into the cluster. So basically, this is done in a loop and we can stop when the maximum number of iterations have been reached. So by assigning samples to the K cluster rather than n samples will achieve the reduction in sum of squares. So as you can see, the sum of square error have reduced here. So after each iterations, we see if the sum of square is decreasing or not. So this is what it is implemented in the k-means clustering.